Hi, this is going to be my physics Rube Goldberg machine video. I have my initial design here. You can see that this was what I designed on the first day. It was not very accurate. It was not really exactly what I did. But this design was what I actually went along with. I actually have the video of my project working right here.
And we come to the second floor.
So as we can see, there's actually 5 energy transfers. So there's that ball, there's a slingshot there that with a rubber band, it slingshots the ball. Ball travels down this ramp, then it hits this orange ball. The orange ball goes down the ramp, and then it hits the broom. So we can see that along the video. For my first law diagram here, we can see that my system included blue ball, orange ball, rubber band, earth, box, and the broom. So the box is what it was on top of. So it might seem weird that the orange ball and broom were included in the system since they're not really being interacted with, but I decided to include them because they had gravitational potential energy, and any object that has potential energy must be included in my in the law diagram in the system. So as we can see, there's US and UG, and then finally there's KE to UG. So calculating UG was very simple. I just had to use the MGH formula here. And then, but calculating US was a bit different since I did not know K constant, but I hung a mass and used I hung a mass over the rubber band. And of course I spread it out the same length as the actual slingshot. So I could solve for K with that, and then with that I could solve for the US. And then by using video analysis, I was able to find the velocity, the final velocity of the objects. So that was my transfer 1. So transfer 2 was when the blue ball rolls down the ramp. Again, I used video analysis to find the velocity, and I calculated the height with a measuring tape for the MGH. So friction here was 0.0375 joules. Oh, and over here it was 0.0024. Transfer 3 was when the ball hit the orange ball. So again, I used video analysis to find the velocities before and after they hit. This way I could find kinetic energy. And then UG stayed the same here. So there's no really transfer. So W friction was 0.018 joules. Transfer 4 was practically the same as transfer 2 because it was a ball going down a ramp. So I'm not really going to go into how I calculated that, but here are the calculations. Friction was 0.039 joules. For transfer 5, that was a bit harder because there was this ball hitting a broom, and then the broom falls. So if you actually look at the video, we see that the orange ball falls down. It falls down from the... Yeah, so like the orange ball falls down after it hits. So I had to calculate the KE of that orange ball, which I did here. I found the horizontal velocity and vertical velocity, and then and by using Pythagorean theorem, I was able to find the whole velocity. And then, can I move that? Yeah. And then I was able to draw this law diagram, and the output energy was 0.36 joules. So that means the efficiency, if you divide it by the input, is 57%. So that was my overall efficiency for my project. So did it fit the constraints? Yes. It had the constraint stated 20% efficiency minimum. I had 57%. Household items, yes. If you look at the video, all my items are household. Nothing was destroyed, as you can see in the video. But I will note that the biggest source of friction was right here. Like if we look at this law diagram of transfer 5, we see that there's 0.15 joules of friction there. So that's a lot of friction. So I believe that it was because of this broom here. Like this in between the stick and the broom. So originally I used this as to hold the broom up, but then I found that there was even more friction when I used that. So then if you look at the final video here, there's actually a pencil instead, and it fit better. So the calculations to prove that was when I used the original one, I had a kinetic energy of 0.02 joules, but when I used the pencil, which fit better, there was 0.12 joules. So that's like 5 times bigger. Or yeah, like 5 times bigger. So the old efficiency was 41%, new efficiency was 57%. So as you can see, there was a clear increase in efficiency due to my revision. So this increased efficiency by 16%.